Hello students, welcome to SV Tech. In this video, I am going to discuss about bus and memory transfer in COA or CO or CA subject. In this class, I am going to discuss what is bus and what is memory transfer and how we are going to construct a common bus using a multiplexer method and three-state buffer method. So before going to the methods, we will discuss what is a bus and what is a common bus. Simply, if you want to transfer data from a B register to A register, that will be written as B to A in register transfer language. Here, if you want to perform this transfer, you have to do two things. From B2 you have to transfer data to bus, and from bus 2 you have to transfer data to A. Here if you have 4-bit register, A is a 4-bit register and individual bits are A0, A1, A2 and A3, and B is an individual register which is the size of 4 bits, B0, B1, B2 and B3. So to transfer data from B register to A register, 4 lines should be there. Means B0 data will transfer to A0 through A line, and B1 data will transfer to A1 through A line, and B2 data will transfer to A2 through A line, and B3 data will transfer to A3 through a line. So this is a story of 4-bit register. But in our computer we have a 16-bit register and want to transfer data from A to B. And then we need 16 lines from A0 to B0, A1 to B1, A2 to B2 up to A15 to B15. Like this 16 lines we will need. But in our computer processor we have thousands of register. Okay, so to transfer data from one register to another register we need lakhs of lines. To avoid this complexity and to avoid this confusion, a common bus structure will be provided. To construct that common bus we have two methods. One is multiplexer and one is three-state buffer. So what is bus? Bus is a simple and efficient way to transfer the information between one register to another register in multi-register configuration system. A bus consists of set of common lines. One register to another register, a set of common lines will be there to transfer each bit from one register to another register, which is binary information transferring. Okay, and the control signal will determine which register is selected by the bus during a particular register transfer. Why? Because we have n number of registers in our computer. In that n number of register, which register we have to select will be decided by control signal. This will be produced by control unit. So to construct this common bus we have two methods. One is using multiplexers and the second one is using three-state buffer. First we will see how we will transfer data or binary information using multiplexers from one register to another register. After that we will discuss about three-state buffer. So before going to the common bus construction, we should know what is multiplexer. Simple, a multiplexer is a combinational circuit which takes n inputs and gives one output. Okay, suppose it take two inputs, then it is called as 2x1 multiplexer. Why? Because it is taking two inputs and giving one output. Suppose if it takes 4 inputs and given one output, so anyway output will be 1, the number of inputs will be changed. So it is taking 4 inputs, so it is called by 4x1 multiplexer. Multiplexer is a simple combinational circuit which can have n number of inputs and single outputs. And one more important point, Simple. If there are n selection lines are there, then 2 power n input lines will be there. Okay, and 2 power n possibilities will be there. I will discuss about this in future also, don't worry. This is a common bus structure using multiplexers. Here, for example, I am constructing a common bus structure using multiplexer for 4 registers which are size of 4 bit. Okay, so the size of multiplexer 4 by 1 will be equal to size of register 4 bit. Suppose if I take 8 bit register, then the size of multiplexer will be 8 by 1 instead of 4 by 1. If I take 16 bit register, the size of multiplexer will be 16 by 1 instead of 4 by 1. Here I have taken only 4 bit register, so the size of multiplexer is 4 by 1. So remember this. This is the important point. And the second one is the number of multiplexers are equal to number of registers. Here I have taken 4 registers. I have taken 4 registers. Register A, register B, register C and register D. Okay. So I will take 4 multiplexers. Multiplexer 0, multiplexer 1, multiplexer 2 and multiplexer 3. If I take 4 registers which are 8 bit register, then size will change 8 by 1. 8 by 1. Okay, 8 by 1 and 8 by 1. Like this, 4 registers which are size of 8 by 1. So the number of bits are equal to the size of multiplexer. The number of registers, I have taken A, B, C, D, 4 registers. That is equal to number of multiplexers. The number of bits is equal to the size of multiplexers and the number of registers are equal to number of multiplexers. Next, here for A registers, I have 4 bits. Okay, I have 4 bits. A0, A1, A2, A3. For B register, I have 4 bits, individual bits, B0, B1, B2, B3. For C register, I have 4 bits, C0, C1, C2, C3. For D register, D0, D1, D2, D3. These are individual bits of my register. So here for multiplexer 0, the inputs are the first bit of each register. Means from A register, A0 will be connected to multiplexer 0, and from B register, B0 will be connected to my first multiplexer, which is multiplexer 0. From C register, C0 will be connected to my first multiplexer, and from D register, D0 will be connected to my first register. This is the story of 1 bit. If you go to second multiplexer, every second bit of my register will be connected to the second multiplexer. So that is A1 will be connected to multiplexer 1 A1, and B1 will be connected to multiplexer B1, and C1 will be connected to multiplexer C1, and D1 will be connected to multiplexer D1. This is the story of my second bit. So, and coming to the third bit of every register will be connected to third multiplexer. Means that is A2 will be connected to A2 input of multiplexer, and B2 will be connected to B2 input of multiplexer, and C2 will be connected to C2 input of multiplexer, and D2 will be connected to D2 input of multiplexer. And the last bit of every register is connected to last multiplexer, which is A3 connected to A3 input of multiplexer, and B3 connected to B3 input of multiplexer, and C3 connected to C3 input of multiplexer, and D3 connected to D3 input of multiplexer. So to avoid this confusion and this complexity, I'm writing only one line, one register line. Remaining will be, you have to imagine, that will be clear, that lines will be there, but I am not drawing here to avoid complexity. Okay, suppose I have taken A3 connecting to A3, B3 connecting to input of B3 multiplexer, like this, and here I have 4 registers, so 2 selection lines will be there. So why I am choosing 2 selection lines means, if you have 4 possibilities, 2 power 2 selection lines will be there. So this 2 is the selection lines S0 and S1, which are produced by the control signal. Simple here, my S0 and S1, these two are my control signals, which are 0 and 0. So the equivalent decimal number is 0. So 0th bit of every multiplexer will be selected. What is the 0th bit of multiplexer 0? That is A0 will be selected. And what is the 0th bit of multiplexer 1? That is A1 will be selected. And what is the 0th bit of multiplexer 2? That is A2 will be selected. And what is the 0th bit of multiplexer 3? A3, that will be selected. Means if the S1 signal and S0 signal is 0 0, the A register bits will be selected and sent to bus. Okay, now if the S0 and S1 is 0 and 1, the equal decimal number is 1, the first bit of every multiplexer will be selected. Okay, what is the first bit of multiplexer 0? That is B0. What is the first bit of multiplexer 1? That is B1. Here you can see like this. So this is 0th bit, this is 0 bit, this is 1 bit, this is 2 bit, this is 3 bit. 0, 1, 2, 3. 0, 1, 2, 3. 0, 1, 2, 3. Like this. Now it is 0 and 1, equivalent decimal number is 1. The first bit of every multiplexer will be selected. That is B0, B1, B2 and B3. Means the B register will be selected if the control signal is 1 and 0. And the control signal is 1 and 0. 1 and 0, the equivalent decimal number is 2. Every second bit of multiplexer will be, input will be selected. That is C0, that is C1, here that is C2, here that is C3. Like this, C register will be selected. If the control signal is 1 1, the equivalent decimal number is 3. The third bit of every multiplexer will be selected. That is D0, D1, D2, D3. Like this, one among the 4 registers will be selected through the selection lines S0 and S1, and that register content will be sent to bus. After that, from that bus, the data will be sent to required register. Okay, this is a common bus structure using multiplexers. This is common bus system for 4-bit register using multiplexer, which are 4-bit. Same thing explained here. The 2 selection lines S1 and S0 are connected to the selection inputs of multiplexers. The selection lines choose the 4 bits of one register, transfer from 4-line common bus. If the S0 and S1, A register will be selected. If the S0 and S1 are 0 1, B register will be selected. If the S0 and S1 are 0 1, C register will be selected. If the S0 and S1 1 1, D register will be selected. So this is common bus construction using multiplexer, very important in COA. Next, coming to common bus structure using 3-state buffer. So 3-state buffer, it is also called as tri-state buffer. Okay, so simply buffer is a logic gate which takes same input and gives same output. Suppose this is the symbol of buffer. Okay, if I give A through it, it gives output A only. If I give 0, it gives 0 only. If I give 1, it gives 1 only. Like this, buffer gate will work. So in this tri-state buffer, for that buffer, we have 2 inputs and 1 output. Okay, 2 inputs and 1 output. One is a normal input which comes from our register, and the second input is the control input which will be sent by control unit. Okay, so if you send normal input, output will be same. If you send A, output will be A. When if C is equal to 1 means control input is 1. If control input is 0, it goes to high impedance state. I will tell what is high impedance state also, don't worry. 3-state gate is a digital circuit that exhibits 3 states. First 2 states are equivalent to logic 0 and 1. The third state is high impedance state, which is like open circuit, which means the output is disconnected and it does not have any logic significance. Means whenever the high impedance state is there, the circuit will be disconnected and there is no output significance. Here we can see in detail about 3-state buffer. The 3-state buffer gate has a normal input and a control input which determines the output state. So with control input 1, the output equal to the normal input. Suppose normal input you have given 0, output is equal to 0. Normal input you have given 1, output is equal to 1. Normal input you have given A, output is equal to A. Normal input you have given B, output will be B. When if the control input is 1. With control input 0, the gate goes to a high impedance state, means there is no determined output will be there. This enables a large number of 3-state gate outputs to be connected with wires from the common bus line without loading effects. Okay, high impedance state means without loading effect we are going to connect all the buses, means there is no operation will be there if control signal is 0. So we will see a simple diagram related to common bus using buffer. So this is a simple 3-state buffer using common bus construction. So here I am taking 4 registers which are A, B, C and D. So the first bit of A is A0, the first bit of B is B0, the first bit of C is C0 and the first bit of D is D0. Here you can see all these bits. The first bit of all registers will be connected to a normal input of tri-state buffer and the control input will be given by 2x4 decoder. Okay, so what is this 2x4 decoder? A decoder is a combinational circuit which takes n inputs and give 2 power n outputs. It is taking 2 inputs which are called S0 and S1, lekapothe S1 and S2. Okay, and it is taking 2 inputs, so it should give 2 power 2 outputs. 4 outputs will be there. So that output will be connected to the control line of tri-state buffer which act as a control signal. Okay, if selection line S0 and S1 are 0 0, the 0 output will be connected to A0. If the selection line 0 1 means the equivalent decimal number is 1, so 1 control signal will be connected to tri-state buffer. If it is control signal S0 and S1 1 0, it is equivalent to 2 decimal number. The second line of control line is connected to tri-state buffer and the decoder produces the selection lines 1 1, then it will be 3 will be connected to the buffer line. Okay, so these buffer will select one of these. Okay, either A0, either B0, C0 or D0. So this is selection of one bit. If you want to select A1 means same structure will be repeated second time. If you want A2 means same structure will be repeated third time. If you want A3 means same structure will be repeated third time. If it is n bit register, same structure will be repeated n times. That only discussed here. Decoders are used to ensure that no more than one control input is activated at any given time. It takes n inputs and giving 2 power n outputs. Okay, here only one decoder is necessary to select between 4 registers. Okay, why? Because it is 2 by 4 decoder, so 4 possibilities will be there. So this is about 3-state buffer. Next, coming to the memory transfer. Memory transfer is a simple definition. There are transferring memory from one component to another component, or one register to another register. Will have two major operations, which is read and which is write. Two major operations. Okay, read and write. So here we will discuss what is read and what is write. So read operation, it is the transfer of data from memory to outside environment. Suppose you are sending data from memory to any bus or any register, then this is called as read operation. Okay, and the second operation is the transfer of the new data to be stored into the memory. Suppose I am sending some data from my register to memory. Okay, if you are sending data from memory to outside devices, it is called read. If you are sending data from outside to inside, then it is called write operation. Okay, MAR means memory address register, MBR means memory buffer register. So this is a simple definition of memory transfer. Memory transfer having two major operations. One is read operation, one is write operation. Read operation means sending data from memory to somewhere. So write operation means receiving data from somewhere. Okay, like this memory transfer will be there. This is the bus, common bus construction and memory transfer of registers. COA, very important question. So if you want to more videos like this, please do subscribe to my channel and share with your friends.